Okay, so we are going to work through solving some literal equations today. But first thing I actually want to do here is a little review, which is to see if we can factor some expressions, because you're going to use this skill in a couple of the equations today. So each one of these at the top has what we call a GCF, which stands for greatest common factor, if I can spell. So what I want to look for here in each of these expressions, these are not equations, is anything that the terms have in common in terms of a number or a variable. In that first question, 4 and 12 are both divisible by 4, and then I have at least an x squared in each of those. So my greatest common factor there is going to be 4x squared. To do the process of factoring here, what you want to do is divide both terms by that greatest common factor. And when we do that, what we do, it's like undoing a distributive property. We're going to pull that out in front. So I'd pull the 4x squared out in front of a set of parentheses, and then you'd tell me what would be left. So in that first term, 4 divided by 4 would just become 1. And I'm going to take 2x squareds out of 3, so we would still have 1x left over. And we'll just keep the subtraction term subtraction in between. Now 12 divided by 4, that's 3. And then x squared divided by x squared would become 1, and so the factored form of that expression would be 4x squared times the quantity x minus 3. If you look at this guy, both of these numbers are divisible by 2, and I have at least an x in both of those, so I'm going to take out a 2x as my greatest common factor. Just like undoing a distributive property, we're going to divide, so the 2x comes out in front. If we were to multiply this back through, it'd give us the original problem. So 6 divided by 2 is 3. We're going to take 1x out, so we'd have 1 left. And then super tricky on this, I think it throws people off. So 2x divided by 2x, sometimes people just think, hey, that cancels that totally out. It does not go away. It exists there. We are not subtracting something to cause it to become 0. We are dividing. So you're not going to get 0 when you do that there. What we're going to actually get, something divided by itself becomes 1. And so in the factored form there, that'd be 2x times the quantity 3x plus 1. And then the last one's probably a little bit more similar to some of the questions you're going to see later on where it's got more variables in it. In between these two terms, I've got just 4c and then the term a little more complicated, ABC. If you notice, I have a c in both of these. So that's actually going to be my greatest common factor there. So we're going to divide a c out in front, just like undoing a distributive property. So all that's left in that first term, c divided by c would become 1, but we also have the 4 there, so it'd just be like 4 times 1, so just a 4. In this term, the c would cancel out, but we'd still have plus ab left over, and that would be our factored form. Now, the rest of what we're going to work on today are called literal equations. And if you'll notice as you look down the page, we've got a bunch of different examples here. These are equations. Really, the only requirement is that they have 2 or more variables. You can see, if you look down at a couple of these examples, there's numbers in these too, but the requirement to be a literal equation is just that you have 2 or more variables in the same equation. Now, we're also going to talk about restrictions, and that's going to be 2 situations. The first situation is in math. You cannot divide by 0. So since a lot of these equations will end up with variables in the problem that we don't know what the variable represents, what you're going to look for in terms of this restriction is if you have a variable in a denominator, so the bottom of a fraction. So that's what you're going to be looking for. Alright, now the second thing, this one is not as common, but another thing you cannot do in math is you can't take the square root of a negative number. Alright, so the situation, I think there's only one problem on here that does this. If whatever you have, if you have a square root, and whatever is under the square root, if that has a variable. If it's just a number, it doesn't matter, but if it has a variable, what you do, you take, not including the square root, whatever's under the square root, and you have to set that greater than or equal to 0. It's okay to be equal to 0, it just can't take the square root of a negative number. So you can take the square root of 0. If you go and write it like this, whatever's under that square root is just saying that's either 0 or it's positive, 0 or bigger than 0. So we're just going to practice a couple questions, and they're just solved for not the variable that you're supposed to work with. So this one says we're going to solve for h. We have a equals 1/2 bh. That's the actual formula for how to find the area of a triangle. So first thing I tell you to do, let's get rid of this fraction. I'm just going to multiply both sides by the reciprocal. So 1/2 times 2, it'll cancel that out. So I get 2a equals b times h. And then from there, to get h alone, I'm multiplying it by b, so I'd have to divide by b to move it. These equations kind of tend to be just a little bit weird because we can't actually simplify a lot of this because we don't know what the variables represent. So it's totally fine. We're going to have letters in these problems. It's like you can kind of see all your steps as you go. And in terms of a restriction, okay, we will have a restriction in this question because I do have a variable in the denominator. So we don't want to divide by 0. The only thing that could cause that to happen is if b were equal to 0. So literally all you have to do for your restriction, you just say b cannot be equal to 0 because that would cause us to divide by 0. That's my restriction right there. In the question right next to this, we're going to get x by itself. Now, this one, people are always tempted to multiply by a first because it's kind of where the variable's that we're looking for. But what I would tell you that people will often forget, you can do that step if you want to, but what people will forget is you would have to multiply every term by a, including the b here. So what I would recommend, if your variable's somewhere where you have terms separate from that, like I have this plus b, get rid of any addition or subtraction first, and then take care of getting rid of any multiplication or division. So here we go. We're just going to subtract b. It's just weird because I can't actually subtract it because I don't know what it represents. Then I want to get the a out of the denominator. Now over here I would have to put parentheses around that expression because I would need to multiply that subtraction problem by a. If you want to go ahead and just leave that in that factored form, you don't need to do the distributive property there just to save us a little bit of time. And then finally, to get x alone, I'm just going to take that whole thing and divide it by 5. Again, it's just kind of weird because we can't actually simplify a lot of the steps, so it's like all our steps are laid out there for us to see as we go through the problem, since we don't know what the variables represent. Now, you don't have to write this. I'm going to on this question, but I don't end up with a variable in the denominator anywhere. So for this question, there's just a 5. So there's no potential for me to divide by 0. I'm just going to be dividing by 5. So this question actually has no restriction I have to worry about. And again, you don't have to write it. I'm just writing it on my notes here real quick. All right, we're going to solve this next one for b. Now, b is within the top of the fraction. There's no separate term or anything here. So I would just start and get that fraction gone by multiplying both sides by 4. 4c equals a plus b. Then all you got to do to get the b alone, we're just going to subtract a. It's positive, so we're just going to subtract it to the other side. So b is equal to 4c minus a. Now, this is similar to the last question. I have no denominator at all, so there's no potential for me to divide by 0, and I have no square root, so no restriction for this literal equation either. All right, and I'm going to do this last one. We're going to get x by itself. Similar to the one above, if you've got terms where your variable you want is next to it to the side, get rid of any addition or subtraction first. So I'm just going to start that out. And I'm going to subtract b. And then you can actually do this all in one step if you want to. 3 and a are both being multiplied by x. You can divide by that entire product at one time. So c minus b over 3a. Now, we will have a restriction here. So you got to think to yourself, okay, what would I plug in for a that would cause me to divide by 0? So basically, whatever's in the denominator, you do not want that to be equal to 0. So I could kind of almost solve this inequality just a little tiny bit And 0 divided by any number, that's legal. You can divide 0 by a number. Can't divide, the 0 can't be in the denominator. But basically the restriction here should just be a can't be equal to 0. And I'm going to flip to the back. Now, on this back page, a lot of these problems are more tricky than what we did on the front. You're going to see the variable that you're looking for is going to be in more than one term. So this one says solve for r, but I've got an r on both sides of this equation. And now there's different ways you could do this. So our answers might look slightly different, but they could still be algebraically equivalent. So it doesn't matter which side you focus on, but you want to get any term with the variable you're solving for, in this case r, on one side, and anything that doesn't involve that variable on the other side. So what I'm going to do here real quick, let me just subtract this r that's in the b plus r on the right side. And if you want to do, you could, I'm going to move this a away, but if you want to do that all in one step, that's totally fine. I'm just going to show you separately real quick. I'm going to move any term that does not have an r to the other side. So that's going to be this plain a by itself. So then I have ar minus r is equal to b minus a. All right, all looks really weird, right? Because we don't have any numbers in this problem at all, so all our steps are just laid there for us to see. What I want to do here is very similar to what we did at the beginning of class today when we were working with the greatest common factor. Both of these terms have an r, which is the variable we're trying to isolate. So to isolate that, what I'm going to do is I'm going to divide both terms by r and take that r out in front and just write down what's left over if I divide that. So we would have a, and then r divided by r. Remember, that doesn't cancel out. That would actually become 1. I'm just going to bring down the b minus a. And now I have r almost by itself, but what I can actually do, r is being multiplied by that set of parentheses. You can actually just get rid of those parentheses in just one step, just like that. The one thing I would caution you on here is sometimes people will say, oh, there's an a here and there's an a here, and they'll try and cross it out. Don't do that. Anytime there's adding or subtracting, you cannot just cancel letters out, because you have to divide b by this a minus 1, and you'd also have to divide a by that a minus 1. I could write that as two separate fractions. A minus 1 would be the common denominator, but I could separate them with a subtraction sign. So nothing cancels there, even though these letters are the same. Now you're like, what the heck, we just canceled out the r up here. This is just one term and one term. There's no addition, there's no subtraction. Same thing here. I canceled out the r's. This a is being multiplied by r though. There's no addition or subtraction within that fraction. As soon as you have that addition or subtraction, you're just going to leave that alone. You can't factor that out in any other way, so those a's do not cancel. Now, this has a restriction because I have a variable in the bottom. So whatever is in my denominator, I do not want that to be equal to 0. And kind of similar to one we did on the front, I'm just going to solve this just a tiny bit. But the thing that would actually cause the denominator to be 0 for my restriction would be if a was equal to 1, because then we'd have 1 minus 1 and we'd be dividing by 0. So that's your restriction. All right, this one, I'm just going to move the 22 real quick. That's the only term that doesn't have x, which is what we're going to try to solve for. And so I can actually just add those numbers together. That's 37. This is super similar to the question we just did. Both of the terms have our variable that we're trying to isolate. So we're just going to undo a distributive property. Now just a plain x comes out in front. It should be, if I multiplied this back through, it would give me the original problem. And then again, this is really similar to the last one. You have x times this set of parentheses. So you can get rid of this set of parentheses. And this one has a little bit of a weird restriction here because I have a plus b. And you can drop the parentheses if you want to do that. Those are, you can use them or not. It's up to you. So a plus b cannot be equal to 0. We have two different variables in the denominator, so I got to make sure whatever we would plug in for a or b, we don't want those to add up to 0. So this is completely fine for a restriction, You might also see, like if you did this on an app or something, they might kind of solve this inequality a little bit like I did for some of the other ones. It would just look like A can't be equal to the opposite of B. That would be a correct way to write that restriction as well. I'm fine with either one of those. Number 7 here. All right, get rid of any addition or subtraction. We're trying to get t by itself. So I've got t squared over a. I'm just going to subtract that 7, b minus 7. We don't know what b is, so we can't actually subtract 7 from it. To get the a out of the denominator, I'm just going to multiply both sides. Because I have a couple pieces here, a couple terms, both of them need to be multiplied by a, so I'm just going to put parentheses. Again, there was a question kind of similar to this on the front. I'm going to put the a in front just for notation purposes. Usually if you're doing a distributive property, you're going to put the whatever you're going to distribute in front, but you don't actually need to distribute it. If you want to, you can, but I would just leave it alone. Then to cancel out the squared, we're going to take a square root, and I'm going to remember here, if I introduce a square root into a problem, there's actually 2 answers to this. I'll do a little problem to the side here in a second, but this should have a plus or minus symbol in front of it. Again, you just leave that whole mess under the square root. That's correct. And you're like, if you're confused, like what's this plus or minus, I'm just going to give you a teeny tiny example. Let's say I had x squared was equal to 49. To solve that problem, you would introduce a square root into the problem. And anytime you introduce a square root, if it's not already there, you have to have a plus or minus symbol because there's actually 2 answers to that equation. If I squared 7 times 7 is 49, that would make that true. However, if I plug in -7 times -7 is also positive 49. So this actually has 2 answers, and that plus minus symbol is just a little shorthand way to write it. So just kind of a little tiny example to the side here. In terms of your restriction, and you don't have to do much here, whatever is under the square root, we cannot take the square root of a negative number. We've got an a and b underneath there. So since I don't know what they represent, to make sure we don't take the square root of a negative number, we can take the square root of 0. So when I say whatever's under the square root, not including the square root, greater than, and I'm going to say or equal to 0. This just means it's okay for this to be 0, and it's okay for this to be any number bigger than 0, which would be any positive number. So this is how we want to write a restriction if you end up with a square root as part of your literal equation. Okay, now number 8, you've got several options here. This is an interesting equation. This is 2 fractions set equal to each other. If you want to, we could try to think of something that would be a common denominator between 4 and 3 and multiply both sides by that to cancel out the fraction. Or if you wanted to, you could straight up start to solve this like a proportion and cross multiply. What we did in class is a lot of people wanted to just get rid of the fraction. So I multiplied both sides by 12. All right, to do that, I just left like a 12 on top in front of that y plus 2. You could distribute it. I'm just going to leave it like this for a second. And then we had like a 12x over 3. So we're picking 12 because we know 4 and 3 both go into 12. That allows us to simplify this. 12 divided by 4. This would just become 3 times y plus 2. This would just become 4x. Our goal here is to get y alone. So if you want to go ahead, this side, I'm going to distribute this just real quick. 3y plus 6. This is 4x. I'm going to move the 6 first. And then we've got 3y equals 4x minus 6. Divide everybody by 3. And this will actually look like the equation of a line. The 4/3 would be your slope, and the -2 would be your y-intercept. So this would be solved for y. There's no restriction here because I don't have any variable in a denominator. This 4/3 is being multiplied by x, or you can think of it looking like this. The x is in the top of that fraction before I simplified that a little bit, but there's no restriction here because you don't have a variable in a denominator. We didn't take a square root. Now, the very last problem here, this one's really hard. The variable you're solving for is y, and you can see I have y in two different spots right away in this equation, and one of those spots has y in a set of parentheses. So what we need to do here to make this probably the easiest is get rid of those parentheses and get a term that has y. To do that, I'm just going to need a little distributive property. If we do end up with two letters in the same term, like both of these actually, you write them in alphabetical order for proper notation. Okay, once I've gotten rid of the parentheses, I'm going to get all the terms with y on one side, all the terms that don't have a y on the other side. And again, there's a couple different ways you could do this, and so our answers could look different, but they would be algebraically equivalent. So I'm just going to add the ay to the other side there. So we have AD CD plus 5y plus ay. And then I'm going to take this term that has the CD, that doesn't have a y in it, I'm going to move that to the other side. So that's positive, so we'll just subtract it to move it. Now, on this left side, you could factor out a d, but it's just extra work, so I'm not going to do it. Our goal here is to get y alone, so you can pull a d out, but it's not necessary. What is necessary is to get a y, greatest common factor, out in front of those two terms that have a y. So we would end up on this side, AD minus CD, we'd have a y out in front here, just a 5 left in that first term, and just an a left in that second term. Ultimate goal here is to get y alone, so once I have this, we can just divide right in one step by this set of parentheses here. And again, you don't need the parentheses, but you can use them or not, it doesn't matter. And again, very similar to a question on the front, don't go, hey, there's an a here and an a here and cross it out. Don't do that. If you have any adding or subtracting, which I actually have both here, you cannot do that. You would have to take this term, the AD divided by that, and then minus CD also divided by that. So we're just going to leave it alone. You cannot cancel that a out. So I know this looks a little complicated, but you'd have AD minus CD whole thing over 5 plus a, or you could write a plus 5, either way. We do have a variable in the denominator, so we cannot divide by 0. In terms of my restriction here, again, I'm just going to solve this inequality just a little bit, and we don't want a to be negative 5, because that would cause us to divide by 0.